Greetings Professor, my name is Umesh Sankuratri. Today I am going to give you a project demo on the topic change detection and evaluation of the kernel-based approach. This project is the result of my 2 months hard work where I had to make a lot of changes in the methodology mentioned in my initial project proposal. All this is done to achieve a more accurate result, keeping in mind the practical applicability of this change detection technique. Let me start with the obvious definition of change detection, which is defined as the process of identifying differences in the state of an object or phenomenon by observing it at different times. This has a lot of practical applications such as land use changes, habitat fragmentation, rate of deforestation, coastal change, urban sprawl, and other cumulative changes. The motivation behind doing this project is the practical applicability of change detection. It's useful in many applications. Let me show you a practical application. This figure right here shows the change detection between the urban growth and the land use detection in Egypt. The red color land is the barren land and all the green color area is the cultivable land. In the year 2000, the red barren land has increased so much due to urbanization and the cultivable land shown in green has drastically decreased. So change detection can be used to point out the differences between the urban growth and land use, as I told now. This is just one of the many applications of change detection. So I'm going to cover a brief introduction of my project proposal and the evaluation of the change detection from kernel-based approach. There were many roadblocks while I was doing this project. Theory demanded a large training set to evaluate and validate it, which became very complex and went beyond my scope. It also required a higher computational analysis which we do not necessarily need, given our basic requirement to complete change detection. Ambiguity prevailed as it's not universal and cannot be applied to a generic dataset. So kernel-based approach cannot be applied to a generic dataset and it had many restrictions. Further research directed me to obtain, most probably by some datasets, to carry forward the project, which is not practically possible. And most of the recommended training datasets were Gloucester flood detection, Greek Island burn area mapping. And again, evaluating the design seemed difficult as it needed a very well-defined independent cost function. And it turned out to be very complex and had many restrictions, as in it cannot be applied to a very generic dataset. So I had to keep in mind the cons entailing using kernels for change detection, and thus I have chosen to embed something logically and achieve my target with more efficacy. I wanted to achieve the change detection with more efficiency and accuracy than the kernel-based approach, and wanted this change detection algorithm of mine to work for universal datasets for any two images. I also wanted to develop a GUI in addition to increase the interactability and universal applicability of my project. So like I said before, my project aims to compare two images and state how same or different the images are. It also projects the distinctions between two images for a plausible reference image drawn by either of them, which I'll be going to show you in the project demo very soon from now. It also captures the most minor changes in the image and make it as accurate as possible. And this feature is also validated through testing. Coming to the experimentation and results, change detection is achieved with respect to the following features: color, image, noise, and blur. A GUI is developed which looks like this. This is the GUI. It has two load image buttons, one check button, one show difference button, and one quit button. And these two are the graphs, histogram graphs, which show the differences between these two images in terms of the contrast or color or whatever it is with respect to the structural parameters of the image. So I took this one as my first test case, which is basically showing the difference between color and black and white images by my change detection algorithm. In the second test case, I used the pre-processing technique. So why did I use this pre-processing technique? I wanted to use an edge detection technique using Sobel filters, which is a pre-processing technique in image processing before the change detection. So this is done in order to prove my point that the algorithm used in implementing the change detection using the GUI accurately detects even the changes between the finest details when comparing two images. So after I give the demo, we can conclude that this algorithm with the GUI interface will detect even the changes obtained after removing the noise and unwanted details using edge detection. So basically what I did was I took the outputs obtained after the edge detection of the same image using two different techniques and supplied these two as inputs to my GUI, to my algorithm. So even then it detected the slightest differences between both the inputs obtained after the edge detection, after the two edge detection techniques, images obtained after the two edge detection techniques, which means that my algorithm was successful in showing even the finest details in an image obtained after removing the noise and unwanted frequencies. Excuse me. So this one is the change direction between two edge detected outputs of the same image. So the output obtained was not the same, and even the graphs look different. You can see the blue line going past the 0.15 mark here, whereas it stopped after it crossed 0.1 here. So my third test case would be showing the differences between a blurred and a normal image. This is in terms of the graph. You can see the difference here, and the result not same here. And I wanted to show you a test case where the results gives 100% same result. So I uploaded the same image twice, so the graphs turned out to be the same and the result turned out to be 100% same. I'll be showing you all the test cases very soon. So let me show you the algorithm. First of all, I wanted to show you the Python algorithm which I use for the pre-processing technique. I was doing an internship with a startup during my fall semester where I had an opportunity to learn Python programming. So I wanted to use Python coding in implementing the edge detection. I used Python predefined functions in the Python library to implement the edge detection technique. So let me show you that. This is the Python code editor Canopy, and these are all the libraries of Python, NumPy, SciPy, which are basically used for the image processing techniques and computer vision. And this key image has libraries, has modules, input output filter exposure image as ing underscore as underscore float. These are all predefined modules inside the Python library used for image processing and computer vision techniques. This two plots module this is the two plots module, which can show the difference between two images in a single figure. So I imported the two plots module, and I'll be going to edge detect the same input using two different techniques, which is the Sobel filter using arrays and Sobel filter using transpose. Let me run the program and show it to you. After I run the program, you'll be getting the images somewhere here. Yeah, I think we got the output here. So this is the edge detection output obtained by the Sobel filter array, and the second one is the output obtained after edge detecting the initial input image with the Sobel filter transpose technique, and this one is comparing the edge detection Sobel and transpose techniques. This one is obtained, the right hand side image here is obtained after edge detecting the image using the Sobel filter array, and this one, the right hand side image, is obtained after edge detection of a black and white image of the same. So I want to take the inputs, these two. So this one is the output obtained by the Sobel filter edge detection array, and this one is the output obtained by the Sobel filter transpose. So I want to take both these outputs as inputs now and supply it to my algorithm in the GUI. Let me first show you how my algorithm works. So coming to the implementation of the algorithm, this part of the code is the implementation block, which initializes the GUI, its name, state, layout, and the GUI calling the algorithm to process the image. The part of the code below that, this is the execution part of the code below, which actually executes before the GUI is made visible. And this dialog icons.mat function is used for loading all the dialog button icons. As part of doing this project, I learned a lot of MATLAB predefined functions and predefined libraries. I got well accustomed with the MATLAB predefined libraries, and these are indeed very powerful tools when being used in the program. This part of the code takes the icon data, and this part of the code implements the GUI. It actually waits for the user response until the figures are loaded into the GUI, and this part of the code is the processing part of the code, and this one is the update and handle structure for the button 1. This is the execution part for the push button 2, that is the image 2, and this one is the update and handles structure part of the code for the button 2, and the part of the code from here to here calls the algorithm to implement the respective change detection. It also pops up any warning dialog boxes if something wrong happens in between, like for example a wrong input is generated or no input is generated. So let me go back and let me run the algorithm for you. This is actually there, and this part of the code actually calls the algorithm which I showed before. When I run this, you get the start program button. When I click that, you get this GUI interface. I'm loading the first image. Let me show you the first test case, which is change detection between a black and white and a color image. This is a black and white image of our professor, and this one is the color image. And if I hit the check button, it says both the images are not same, as one is color and one is black and white, and the changes are depicted in the form of the graphs histogram. Here you can see the differences with respect to the color and other structural parameters. And when I hit the show difference button, this one shows the difference between both the images with respect to each other. Let me move forward with my second test case, which is basically comparing two edge detected outputs of the same image and showing both of them are different. This is the edge detected image, and the second one would be edge detected 2. So this image is obtained after the edge detection using the Sobel filter array, and this one is obtained after the edge detection using Sobel filter transpose. Let us check the difference between. So both of them are not same. Again, there is some difference in the minute details or the slightest details between two different edge techniques.
So my point is to prove the efficiency of the algorithm here in detecting even the slightest details of two edge detected outputs of the same image. So when I hit the show difference, this one shows the difference between both the images with respect to each other. Now my third test case would be showing differences between a blurred and a normal image. So this is a normal image, and this one is a blurred image. Let's check if both the images are same or not. Both of them are not same. Even the graphs show that both the images are not the same. You can see the difference here. And when I hit the show difference button, it shows the difference between both the images with respect to each other. Like for example, these boxes right here, these are the differences with respect to each other. And let me show you a test case where both the images are similar. I'm uploading the same image twice, which means I'm trying to detect changes between the same image uploaded twice. So this one says both the images are 100% same, even the graphs appear to be the same. Right, the show difference, there's no difference at all. So you can see a totally blacked out image, which means there's no difference at all. Whereas for the previous test cases, you can see the difference between both the images, like for example, like difference between both the images with respect to each other. But in this case, since both the images are same, there's no difference at all. My last test case would be difference between a normal image and a zoomed in image. Like for example, this one. And this one. Even though both of these images appear to be the same, they're actually not. The right side image is cropped on the right hand side here, and even the top part is cropped. So let's see if my algorithm detects the changes between these two images. Yeah, it does. Even the graphs show the difference, and when I hit the show difference button, this one shows the difference between both the images with respect to each other. This is the difference part. So this is my project, change detection using a GUI interface. So most of my work has been inspired from the paper proposed by Michel Volpi, Davis Chua, and Gustavo Camps Wolf on chain detection with respect to algorithms between two images. So then I developed the idea that why can't I detect the changes between two images in the form of graphs? And later I want to develop a GUI to increase the interactability. So to summarize my work, I've coded and improvised on different aspects of the initial proposed paper. Improvisations include applying an optimum pre-processing technique like edge detection using the Python coding to minimize the noise in the image, and then using it for change detection to portray the efficiency of the algorithm. And the second improvisation would be creation of a GUI to implement my change detection algorithm for added interactability in using the application. So this concludes my project. Although both the images appear to be the same, they're actually not. And my algorithm successfully depicts the change between the images. Thank you.